So this one, again, we're just going to be applying the Pythagorean theorem. What is the length of the dotted line in the diagram below? Leave your answer in simplest radical form. All right, so we got, well, there's kind of three triangles right here. First off, let's look. Okay, so I have this, we're going to call this a rectangle. It kind of looks like a square, but we can't guarantee that it is going to be a square. Which means we've got to look at this triangle right here. All right, now I'm going to take this triangle and separate it. Let's see if I can do that. That's okay. And we can see, based on where that right angle is, we have two legs. We got a leg that's 4 and a leg that's 8. So I'm going to have to take this triangle, and I'm going to have to solve for the hypotenuse. Once I have this value, the hypotenuse, then I will have this length of this rectangle. Now, if that doesn't make sense what we're going to be doing after that, that's okay. We're going to go over it. Let's take a look at this. So we got this triangle here. A little bit more space, though. There we go. Okay, so my first leg is, I'll say that's the 4. And then the second leg is 8. We are solving for the hypotenuse. So that would be 4 squared plus 8 squared is going to equal the hypotenuse squared. Like this, if you want to evaluate each part, 4 to the power of 2 is 16. 8 to the power of 2 is 64. And when we add these together, we should get the hypotenuse as a square. Now combining these, looks like we get 80 equals the hypotenuse as a square. Like we've seen, we don't want the hypotenuse as a square. We just want, in the end, the hypotenuse. Now this is just the hypotenuse for this triangle. There's going to be others that we need to consider. But since I want that hypotenuse, I'm going to have to take that hypotenuse to the power of 2 and square root it. But if I do that to one side, I've got to do the other side. And I'm going to round this, it says, to leave your answer in simplest radical form. So I guess we might have to do that. So start out, I'm gonna take the square root. So remember the top left, we've got second and then the x squared button because that's where the square root symbol is. And then I will type 80 and then I can push enter. And when I do, I get this decimal. Okay, and that's pretty good. It's just that it's not simplest radical form. Okay, so that means that we're going to look at this square root of 80 right there, and I'm actually going to leave that alone as the square root of 80. Well, let's see. So another way to do this, especially since we're not looking for the answer right now, is instead of writing this decimal, I'm going to write it simply as the square root of 80. Now that isn't fully simplified, but we're going to see if it needs to be simplified. So we're not going to worry about the simplification process right now. But what I know now is that for the triangle that we broke off right here, let's see if I can do that better. This one, that wasn't much better, but that hypotenuse is the square root of 80, which we know is about 8.94427,191. Which means that this length right here on our original figure is also the square root of 80, which is more exact than 8.94427,191. But now that I have this length right here, this is a rectangle, meaning that this length also is going to be the square root of 80. Now I'm putting this here, even though we don't necessarily need it there. Because by taking this rectangle and splitting it in half this way, from corner to corner, what we do is we create two congruent triangles right there. So it doesn't matter which triangle you want to use. It's really up to you. I'll use that. I'll use this one right here. Okay. So we're going to take that half rectangle, and we're just going to look at this part of the rectangle, half of it cut from corner to corner, which gives us this triangle. So I can see that my purple length, which is now become a leg, is at the square root of 80. It gave us this length right here, which is 10. So that's going to be equivalent to this one right here, because opposite sides of rectangles are the same. And so this length is 10. Which means that for this problem, we are trying to find this hypotenuse, which is what it was asking for in the first place. We want to find the length of this dotted line. So we're back to the Pythagorean theorem. So we used the Pythagorean theorem once for the original triangle, but now we're using the Pythagorean theorem for this triangle. And even in the original figure, we're showing this right angle mark right here, 90 degrees. So we know that we can use the Pythagorean theorem, but we have two legs. I've got one leg that is showing as the square root of 80. The other leg is showing as the value 10. What we don't have is the hypotenuse. So we're going to take that square root of 80 and square it, which we can do in the calculator, plus 10 to the power of 2, and this would equal the hypotenuse to the power of 2. So we'll use the calculator once again for this, and we'll see what it gives us. All right, the square root of 80 to the power of 2, that's just going to be 80, because the exponent 2 and then the square root are going to essentially undo each other, but you can say cancel each other out. 10 to the power of 2, 10 times 10 is 100. When I add these numbers together, I get the hypotenuse to the power of 2. And by combining these, we've got 80 plus 100, which is 180. This is the hypotenuse to the power of 2. What I would like, though, just like we had before, is not the hypotenuse to the power of 2, but just the regular old-fashioned hypotenuse. So I'm going to take that hypotenuse to the power of 2 and square root it. And if I do that to one side, I must do it to the other side as well. So once again, the calculator is going to give us, a pretty ugly looking number. Okay, this is the decimal value that we do not want. That is garbage. Because up there at the top, it says that we want to leave the answer in simplest radical form. Now we could simplify this if we wanted to, and in fact I will do that, just to show you how much fun it is. Okay, so I'm going to go back to the square root of 180, where we square rooted, to get the hypotenuse, because the hypotenuse itself is the same as taking the square root of 180. So this goes back to 8th grade stuff, which we've probably forgotten, and that's okay, because we're going to review it right now. So what I'm going to do is take the square root of 180. I'm just looking at the 180, and I'd like to factor it, meaning I'm looking for values that I can divide it by, specifically that are perfect squares, such as 1, 4, 9, 16, 25, and so forth. So I look at this one. Looks like we could divide it by 9. Let's see what happens when we do that. So that'd be 180. Two factors would be something like 9 and 20. And you can use a calculator for that. I don't want to do that. We can do more. We can do more with that. So it looks like we could do, if I were to divide it by 36, it'd be 36 and 5. Yeah, that looks better. You could have used, if you wanted to, the factors of 4 and 45, it looks like. But again, that's not going to help us right there. Because we want the biggest factor of 180 that is a perfect square. Now that may take some guess and test right there. Again, I'm just kind of showing you how awesome this is. We want the biggest one, so we're going to take the square root of 180, and instead of showing it as the square root of 180, we're going to show it as the product of two factors, such as 36 and 5. 36 again, because it is the biggest perfect square factor of 180. Now we can take the square root of 36, which is 6. Almost put 4. And then the square root of 5 just stays the square root of 5. And this right there is the hypotenuse, which is also the length of this dashed line right there. Okay, so that's my answer in simplest radical form. Now let's say that you didn't really enjoy that process, which is pretty common, because, I don't know, most people your age don't like this stuff. The other method is to use a calculator, which I have. Not these ones, though, not the TI-84s, because I don't know how to make these TI-84s do it, but I do know how to make a TI-30XS do it, which is the multi-views. If you want one of these, just let me know, but let me finish this. So in this calculator, I push second x squared again, and then I just type in the number, 180, I push enter, and this calculator says, I mean, you'll never believe it, but it says 6 times the square root of 5. Now, it's not showing the multiplication, but it's there. It says 6 times the square root of 5. I didn't have to do any of this work right here, as fun as it was. It's just done. Okay, so again, this 6 times the square root of 5, which we already know is 13.41640,786. That's this length right here. We found it both in decimal format and in its simplest radical form, which would also be another way to say we want the exact value.